Hi, it's time for part 2 of our 1939 NuTone Series 2 gear drive disassembly videos. So the last time we visited our gear drive assembly, you got to see me take it apart, you got to see it go on fire, and I pulled it apart to some degree, and everything was greasy and dirty and in really difficult shape to do anything with. Since then, it's all been thoroughly cleaned. And as you can see, and if you haven't seen the first part of this series, there'll be one of those banner things that pops up right over here somewhere, and you can go watch that and see. You should, because it's a good video. It shows how to take this apart. And everything has been thoroughly cleaned. To get all the hardened grease and stuff out of it, I soaked it in a solvent for a few days and then very carefully cleaned it. That got a lot of the bulky junk out of the inside of it. To make it even better, recently I purchased a small ultrasonic cleaner to use on door chime repairs and clock parts. All of these parts went in the ultrasonic cleaner and they were all cleaned also that way, so everything came out really clean. The trickiest part of the whole thing seemed to be on all of the different little gears, and this is one of them. In the little teeth of the gears, there was a lot of hardened grease in the little grooves, or the teeth of the gears, and I very carefully sat there with a really small little pick and scraped each one of them out and cleaned them and then put them in the ultrasonic cleaner, and they all came out really well. As I showed in the first part of this series, I have everything separated out by which gear number they are, because they have to go back in the case the way they came out, so they each have their own little individual numbered bags so I don't lose them or mix them up. Now we're going to see if we can sort of reassemble it to some degree. Before we get to the reassembly part, let's take a look at something really interesting. One of the viewers of this channel, a fella named Tim, sent me some interesting information. He sent me copies of patent documents for what turns out to be this motor assembly. And I'll put this like this so you can see it. This is exactly the same motor assembly that came out of this NuTone 1939 Series 2 door chime. It turns out that this motor assembly was made by a company called, it's the Leich Electric Company, L-E-I-C-H, and they were located in Illinois. This patent is patent number 2,157,435, and the patent date was granted on May 9th, 1939. What this patent document describes and explains is primarily a patent for what's called a synchronous motor. It has all to do with the motor assembly, not so much the gear drive assembly. There's actually only one very small part in here that addresses the gear drive itself, and that's on page 1. It's number 25 on page 1, and it says the field laminations are held together and to a housing by a plurality of bolts. The housing desirably contains a gear reduction unit not shown, and provides bearings and for a rotor shaft and a driven shaft respectively. The mounting ears are provided on the housing. These ears are apertured so the motor and housing can be mounted upon a supporting structure by means of screws, bolts, rivets, or the like. And that's all it really says about the gear drive. I would assume that the motor was the important bit that they were patenting, because back in these days, synchronous motors were all the thing. The gear drive assembly could, I assume, be designed and modified and changed for lots of different applications, and they were mostly interested in patenting the motor itself. The patent was filed on April 12, 1937, so it took a little over 2 years for them to grant the patent for the motor, which was good. So now we know where these motors came from. Who is the Leich Electric Company? Well, from what, and if you Google them, you'll find out information about them. They were primarily a company that manufactured telephone equipment, not only for residential use back in those days, but also for commercial and industrial or office type use. They had essentially the 1939 version of office phone systems, and it turns out that back in those days, Western Electric was probably the single largest manufacturer of telephone equipment in the United States, and the Lick Electric Company was number 2. And they went through a lot of changes and were acquired by other companies and so on and so on, but they were a big player in the telephone world, and that could possibly be why this is a 24 volt motor or 20-ish volt motor. It doesn't actually say, because a lot of telephone equipment in those days was all designed around 24 volts, so that may or may not be true. I don't know. The inventors are credited as Alexander C. Reed and Harold J. McCrary. This is an interesting document, and it clears up one of the mysteries about what these motors are. So let's go ahead and get to our little gear drive assembly and see what we can do, and see if we can reassemble it and figure out if there's anything wrong with it or not. If you recall, we'll put these off to the side for the minute. And we'll put the winding assembly off to the side because we're not concerned with that actually right now. So this is the gear drive enclosure, and there's the little gear here in the center. This was the gear that was loose, this one right here, when we disassembled this, and I think it was loose because someone had tried to pry off this part of the rotor assembly, and that was the wrong thing to do, and by prying on it we popped the gear loose. So that's been all cleaned and reinserted onto its shaft where it belongs. The other thing that's important to remember was the orientation of the gears. There are actually 5 pivot points or axle points in the case itself, 1, 2, 3, 4, 5, and this one on the left is number 1. So each of the gears were carefully cleaned, and one of the things I found interesting when I was cleaning the gears is this is gear number 1, and gear number 1, the actual large diameter gear here, it's actually some kind of fibrous material. It's not metal, it's not brass, I don't think it's Bakelite necessarily, but it's some kind of fibery gear material instead of being metal. The little tiny gear on the bottom of it right here is metal, as is the shaft. So this one sits in first, and we're going to see if we can do this so you can actually watch. So if we hold this like this, this gear fits down in here like this, and of course everything is a little bit wobbly, and the way this lines up, as I tilt it, everything's going to always fall. The outside teeth of the large gear mesh with the teeth of the small gear in the center, which is what turns it. And then we have gear number 2, which sits in the next pivot point like this. It's a little tricky because they want to fall around as you put them in place. And then we have gear number 3, like this, and then we have the last and final gear number 4. And what these do for the most part is it is a gear reduction drive assembly. The armature of the motor spins at a fairly high RPM, and as it turns the gears, it reduces the RPMs. I believe the motor itself is around 4 RPMs on the output shaft, and not only does it reduce the speed of the shaft, but also it would therefore increase the torque or the twisting power that the motor has. Then we have this top plate, and the top plate is interesting because, put this down, all the gears will probably fall out again. It actually goes this way. It has this triangular piece here, which is riveted to the heavy, I think, brass ring, and it provides a pivot point for the center gear with the output shaft. And around the circumference of the opening in the center of the plate, there are holes, and those are where the shafts for the 4 little gears pop through, and that's what holds them up straight and so forth. So the tricky part here is you've got to keep all the gears in their appropriate spots, and then you have to try to insert this so that it's a little hard to do on camera. like that. And then the tricky part is going to be you've got to get all of the little, basically axles of the gears through all the little holes in the plate, and you have to do it all kind of at the same time because they're all the same length, and so it's a balancing act. It's a lot like one of those games, the little wooden boxes with the clear covers, and you've got a bunch of little ball bearings in it, and you've got to jiggle it around to get the ball bearings in the little divots and keep them all in at the same time. So if you were good at that when you were a kid, you probably would be pretty good at this. And I've got 4, and now they're all in. So you can see the top of the 4 gear axles poking through the little holes, and here's the triangular plate that's riveted on the bottom, and that's where this gear is going to sit in next. Now, if I hold this like this to keep the plate flat, and I turn the armature, it sometimes wants to engage and sometimes not. And so it's a matter of having it contact the first gear, the teeth in the first gear correctly. And of course, what makes this tricky is by the time you put this piece on, you can't really see inside anymore, and now you can see because I was messing around, it's popped off. So let's lift this off and see if I can see how this is supposed to sit in here, because it seems to me that on this, I'm going to hold this, on the armature here, there's a certain amount of end play. See, it moves in and out. And when you read through the patent information about this, the way this is designed, when the motor is energized and it turns on, the amount of end play, the moving back and forth, is designed to sort of center itself in the middle of the plates and run evenly. So it sort of takes up its own play as it goes. And you can see maybe I'm turning the armature with my finger, and you can see the small gear is turning gear number 1, which is turning gear number 2, and it's supposed to be turning gear number 3, but it's all a little wonky right now. So it's a little hard to know exactly how it's all supposed to be set up, and it will take a fair amount of playing around, because of course every time you mess around with it all of the little gear axles come loose, and then you've got to set it all back up again, being careful not to damage anything. See, I had 4, 3, 2 in, and then I got 1 in, but then 4 popped back out, and now 4 is in, but one's out, and now they're all in. So maybe now, so I don't know, you probably won't be able to see that, or maybe you can. If I spin it with my finger, it was turning, but then it seems to hang up, which is sort of the problem we had originally before I took it apart. I think it has something to do with where the armature, or the end play of the armature, where it is on the in and out motion, so it lines up correctly, because when it's pulled all the way out, it seems to turn the gears properly, and you, I think, can see at the bottom there's sort of a light colored gear, and I think I can see, and you should be able to see, the teeth moving. So that's how that all goes together. And then the center gear sits here, and the teeth on it mesh into the small gear. See, I just pulled it all apart again. So it's complicated and it's difficult. So what I'm going to do is I'm going to put the gears back on top of their little storage bags, because we absolutely definitely don't want to get them mixed up. And you have to be particularly careful of the fiber gear because it's got these 3 holes in it. And so on the outside edge of the holes where they're next to the teeth around the perimeter of the gear, the fiber material is very narrow, and you don't want to force it in any way because I have a feeling it would probably break pretty easily, and the odds of ever finding a replacement are probably 0. So hypothetically, once you get this all put back together and then you put this back in the center and it all meshes up, then you take the cap, which is the part we desoldered, and this shaft fits through the cap. Now, one of the things when I took this all apart, and if you watch the first video, you'll see there was a lot of bubbling up grease that was coming up through the space between the bearing and the shaft. And once I got this all apart, this was pretty well stuck in there. And one of the things was the end of the shaft here, where the contact that rotates on the chime is attached, there's a little grub screw that tightens down on it. This was all sort of gouged up. So I took some fine sandpaper and sanded it smooth to get rid of the rough pits and the roughness on it. And then it was able to slide out again. So, because this should turn freely, but it has to be a close enough tolerance so the oil doesn't leak out when you fill it up, and there is no seal or anything like that. It's just a bearing and shaft connection. And I cleaned the solder off the edge of this to get it back to its original size, and then ultimately when this is all back together and it works, you insert this back in here like that, and then you would just simply flow solder around the joint again to seal it up, hold it in place, and help prevent the grease or the oil, it'd be oil, not grease, from leaking out. As for what kind of oil, who knows? Any kind of lightweight instrument oil should be fine. And then the other question is how much, and I think that the how much should be not too hard to figure out. There is the little fill hole right here, and there's a screw that goes in there with a little fiber washer to keep that from leaking. And the way I would approach this is, for any of you who might have ever worked on a car and changed the oil in a differential, that's the rear end of the car, by the way, typically they're not filled up all the way. Most of the time they're filled up roughly halfway, give or take, depending on what the manufacturer says, but you don't fill up the differential all the way with oil. You need some airspace in there, and the whole point of something like that is as the gears turn, and with the viscosity of the oil, which is how thick it is, if it's the right viscosity and it's the right type of oil, as the gears turn, the teeth of the gears pull the oil up with the gear as it turns, and it sort of sprays around. You know, differential turns really fast, this turns really slow, but the idea is the same. The gears pull the oil up and distribute it around on the other gears, and that keeps everything lubricated. So I think a little less than half would be the way to go, because if you also think about it, when this is reassembled and this sits in the chime like this, you would want the oil to be just underneath this point here, or underneath the bearing itself, because if you fill it up above the bearing, I think this gap here between the shaft and the bearing, I think it would leak out over time pretty readily, and you don't want that because it's going to make a big mess out of the chime. So I think just below that would be enough. So before I get all this put back together, hopefully at some point I'll have to measure how much that would be and then know how much to put in there. So that's sort of the first follow-up on this. I've got more I have to do because I have to figure out, this is hard to get out, it's a fairly tight fit like that. I have to figure out about the gear drive assembly. I have to figure out about the end play of the armature, and I also have to figure out the little gear in the center, the one down in there. It's not symmetrical end to end. One end has a sort of a flat side to it and the other end doesn't, and it may be that right now it's upside down. It may need to come off again, and I might have to flip it over and then put it back down, because it seems to me like if it's going to turn all the time, you would want the flat side of the gear here to rub on the hub in the center. But I'm not sure about that yet, and so I have to play around with that some also. It's something that's really old, and there's not a lot of really good information about it. There is a lot of really good information about the motor itself. In fact, I think we might all benefit from a little bit of bedtime reading. Let's read how a patent document is written, because it's not written in ordinary English like you or I would use. It's written in some sort of patent document legalese type description, and while the description is fully a little more than 2 pages long, a really small type, it seems to go over the same things over and over and over again in an attempt to make sure, I suppose, that you describe it in every way humanly possible, so you don't leave out some way that it could be described that some other company could steal and say, no, we said it that way, now it's ours. So we'll just read a little bit of this, because if you're watching this late at night, you probably need something to help put you to sleep. So we'll just do the first maybe 2 paragraphs, not too long. We'll try not to stumble around on it too much. The present invention relates to a self-starting synchronous motor of the general type in which a rotor of magnetic material is caused to rotate by the influence of a rotating magnetic field. See? You feel sleepy already. The motors, such as described above, use a field magnet excited by a winding from the source of alternating current. And remember, back in those days, there was the alternating current and direct current fight going on in the world. The field winding has a plurality of polar projections providing circumferentially spaced poles, particularly shaded by utilizing shading coils on certain of the polar projections to create a rotating magnetic field. These are the polar projections, these flat bars right here. They're the ones that create the rotating magnetic field. Now I've lost my place. This type of field, when used with a rotor element of magnetic material of ring form, that's this part right here, let's see, which was broken transversely to provide a gap in its circumference, has the disadvantage that the rotor tends to become locked stationarily at those positions of the rotor where the space between the polar projections is aligned with the gap in the rotor. Exactly. That's always been my worry about this. Heretofore, this tendency has been overcome by modifying the field structure in such a fashion as to produce an overlapping field zone at the space between the opposite poles. Well, finally somebody figured it out. Gosh. The present invention contemplates the provision of a rotor structure therein. This tendency to remain in a definite position is further overcome at the starting of the rotor and accomplished in a more efficient manner. This rotor construction enables the motor to be started with the lower voltage of the exciting winding, furthermore making it possible to bring the motor up to a synchronous and develop more power synchronous speed. Rings of the permanent magnet steel have been used heretofore in rotors of this character. However, when the highest rentivity, nobody can say that, of the metal is obtained, difficulty has been encountered in preventing locking in of the rotor. We have found the highest rentivity is of value in obtaining high torque for the motor, and for this reason we employ a rotor in which the bands have the highest magnetic rentivity, and we are able to obtain. So they looked really, really hard for a special kind of metal. For example, we have found that the bands cut from tungsten steel and properly heat treated give us an excellent rentivity. The bands are heated to a temperature of 1425 degrees Fahrenheit to 1450 degrees Fahrenheit and quenched to harden them. And what they're talking about is the little curly part right here that's wound around the aluminum hub. And this is the key to the whole thing. And basically, if you read the whole thing, what they're describing, because this piece of tungsten that's been specially wrapped and heat treated, and it's cut off on the ends right here. and it's wrapped around and around in sort of a spiral on the aluminum hub because of the way this is designed and the type of materials that they used. When it's all put together and it's back in the frame like this and it's all bolted together, and you supply electricity to the coil, which makes the rotating magnetic field. The rotating magnetic field, because of the bars here, cause this to spin. And because of the way it's designed and because of all the special materials that they use and all the thought and effort they put into it, it can be turned off just like it is here, and you apply power, and because it's such a swell design, it immediately starts to spin all on its own. Where if it had been designed a different way, the way other motors were made, it may not want to start, it may be stuck or stalled, and it would take someone to spin it to get it going again, and that's not what you want, because when you're designing a door chime or perhaps some kind of fancy commercial telephone system in 1939, when you want something to turn on, you want something to turn on. Even though labor was cheap in those days and you could probably pay a guy to go over and spin the motor every time it's supposed to start it, you don't really want to do that. You want something that starts on its own. You have to remember, these are back in the early days of motors still. Now we take it all for granted nowadays, but back in those days, lots of innovation. Guys were trying to come up with the better motor. I hope you found this interesting, and perhaps for somebody it might be helpful. There's more to do on this. I still have to figure more of it out, but we are making progress on it, and my goal here is to try to get this fixed and have a spare, because that would be swell. I've looked for other motors like this made by the Lick Electric Company, and so far, no luck. Haven't found any anywhere. I haven't even found any products. Some of their catalogs and things are online. You can look at the things that they made back in those days, and I don't see anything for buy motors or that the motors were used in, so I don't really know what the application was, but I'll keep looking every week, and eventually I'll find some more, because that's what I do. I hope you found this interesting, and perhaps for somebody it'll be helpful. If it is, please give it a big thumbs up, because that helps us just a little bit. A special shout out to Tim, who sent me this information and was interested in this. I really appreciate it. Help from outside people on obscure things is always welcome. So there'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications, and every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.